Sometimes when you're using the integration by parts method, you'll notice that the integral that you started with reappears on the right-hand side of your formula. And so I call this the resurrection because you start off with some integral and it reappears again later. Now, at first, when this happens, you might think that you've actually gotten stuck. In actuality, you can solve this problem. The way that you solve it is by adding this integral of a dx to both sides. So I add this integral back over to the other side. That gives me 2 times the integral that I started with equals something. And then all I need to do is divide both sides by 2. So the integral that I started with is equal to 1/2 of this b. And you would want to add your constant of integration as usual. So in summary, if you have this situation where you have the integral of something equals some quantity minus the integral that you started with, that implies that the integral that you're trying to solve for is 1/2 b plus a constant of integration. So we'll look at an example where this happens. It often happens in these situations where you have like e to the x times some cosine or sine and similar types of problems. So we're going to try and use the method of integration by parts. We need to figure out what we're going to set u equal to. And so I look at my y-at list. No logs, no inverse trig, algebraic. But there is a regular trig function, cosine of x. So I'm going to go ahead and let u equal cosine of x in this problem. Remember, once you know u, that implies what dv is, because dv has to be everything else. Here it's going to be e to the x times dx. Once you know u and dv, you need to figure out du and v. We start by finding du. We find that by calculating the derivative of u, which is negative sine, then you multiply by dx. Next, I need to find v. I do that by integrating my formula for dv, and the integral of e to the x is just e to the x. So I have all the pieces for the integration by parts formula. Now I need to plug it all in. U is cosine of x. Both of these v's get replaced with e to the power x, and du was negative sine of x dx. As usual, after I plug everything in, I want to look for ways of simplifying. I notice that I have a minus and minus. They can combine to a plus. So the integral that I have now, this integral of e to the x sine of x, that is a lot like the one that I started with, but instead of having a cosine, I now have sine. So it looks like applying an integration by parts turned this cosine into sine, and maybe if I apply it again, it's going to turn this sine back into cosine. That's the hope. Let's see if that works. So we're going to use integration by parts again, just to figure out this new integral that we have. So this is our current progress in the problem. We're focusing now on finding the integral of e to the x sine of x. And we're using integration by parts again. So here we again have a trig function. That is the first function type that appears on the y-at list. So I'm going to let u be sine of x. That implies that dv must be e to the x times dx, same as it was in the last application of integration by parts. Next, I find du. In this case, the derivative of u is cosine of x. Then we multiply by dx. V is again going to be e to the x, because the integral of e to the x is e to the x. So I have everything. I'm going to plug it in. U is sine of x. Both these v's are e to the x. And du is cosine of x times dx. Nothing really to simplify here, but let's get rid of all these unnecessary parentheses. So this is just the same expression without parentheses. What we've shown so far, or in this slide at least, is that the integral of e to the x sine x is equal to this entire expression here. And so we can replace this part of the formula with the expression that we just found. That's what I'm doing here. So e to the x times cosine of x plus this integral, and we replace that integral with this expression. In the expression that I have now, there's actually still some more that I can simplify because I have two terms that have a common factor of e to the x. So let's go ahead and factor that out. It was multiplying a cosine x, and it was multiplying a sine of x. Now, what I want to notice is that we have the integral on the left is the same integral that we have on the right. In other words, what we're looking at now is an example of what I was describing at the beginning. We have the integral of something equals b. b is this entire expression right here, e to the x times cosine of x plus sine of x, minus the integral that we started with. So we can apply this principle, and if we do that, we get that the integral of e to the x cosine of x is 1/2 this quantity. So 1/2 of e to the x times cosine x plus sine x. Then we just add our constant of integration at the very end of this expression.